Basic Concepts in Chemistry by Anandovsky. Matter. Matter is anything that takes up space and has mass. That cat takes up space, so it is matter. Matter can change states through physical processes like melting, boiling, condensation, and freezing. Matter is made up of tiny particles, primarily atoms, composed of protons, neutrons, and electrons, which can combine to form molecules, ions, or larger structures. Four states of matter are observable in everyday life: solid, liquid, gas, and plasma. There is one more, a Bose-Einstein condensate, BC, is not directly observable in real life with the naked eye because it requires extremely low temperatures near absolute zero. The primary difference between states of matter, solid, liquid, and gas, lies in the arrangement and movement of their particles, where solids have tightly packed, fixed particles, liquids have loosely packed, flowing particles, and gases have widely spaced, rapidly moving particles. Plasma consists of ionized particles with high energy and free-moving electrons. When atoms chemically combine, the following laws govern the process. We can call it the law of chemical combination. They are: 1. Law of conservation of mass. 2. Law of definite proportions, or constant composition. 3. Law of multiple proportions. 4. Law of conservation of energy. 5. Octet rule. Law of conservation of mass states that mass is neither created nor destroyed in a chemical reaction. The total mass of reactants equals the total mass of products. Law of definite proportions, or constant composition, states that a given compound always contains the same elements in the same fixed ratio by mass, regardless of its source or how it was prepared. Example: water. Law of multiple proportions states that when two elements combine to form more than one compound, the ratios of the masses of one element that combine with a fixed mass of the other element are simple whole numbers. Law of conservation of energy states that energy cannot be created or destroyed during a chemical reaction, it can only change forms. Example: from chemical energy to heat. Octet rule states that atoms tend to combine in ways that allow them to achieve a stable configuration with 8 electrons in their outermost shell. Exceptions exist, such as hydrogen and helium. This rule predicts how elements will bond and form compounds. Okay, why and how particles combine? Particles chemically combine to achieve stability by forming chemical bonds, which occur due to interactions between the electrons of atoms. This can happen through ionic bonds, covalent bonds, or metallic bonds. Dalton's atomic theory laid the groundwork for modern chemistry by providing a clear framework for understanding the composition and behavior of matter at the atomic level. It helped to explain why elements combine in specific ways to form compounds and how chemical reactions occur. Dalton's atomic theory says that all matter is made up of indivisible particles called atoms. Atoms of an element are identical. Atoms of a given element are identical in mass and properties. For example, all carbon atoms have the same mass and chemical properties. Atoms of different elements are different. Atoms of different elements have different masses and properties. For instance, oxygen atoms differ from hydrogen atoms. Compounds are formed by the combination of atoms. Atoms combine in simple whole number ratios to form compounds. For example, water. Chemical reactions involve the rearrangement of atoms. During a chemical reaction, atoms are rearranged to form new substances. Atoms are not created or destroyed in the process. Chemical reactions showcase the application of atomic theory in real-world scenarios. By studying reactions, we can see how Dalton's principles, such as the conservation of mass and the combination of atoms, operate in practice. Let us look at some chemical reaction concepts. Atomic mass. Atomic mass is the average mass of an atom of an element, measured in atomic mass units. Molecular mass is the total mass of a molecule, calculated by adding the atomic masses of all the atoms in the molecule. 1 mole of any substance contains approximately 6.022 into 10 raised to 23 particles. This number is known as Avogadro's number. Molar mass is the mass of 1 mole of a substance, usually measured in grams per mole. To find the molar mass, you add up the atomic masses of all the atoms in a molecule. Percentage composition tells you the percentage by mass of each element in a compound. To find the percentage composition, you divide the mass of each element in the compound by the total mass of the compound and then multiply by 100. The empirical formula shows the simplest whole number ratio of the elements in a compound. It gives you the basic composition without indicating how many atoms are actually in a molecule. The molecular formula shows the actual number of each type of atom in a molecule of a compound. It provides more specific information than the empirical formula. Chemical reactions. A chemical reaction is a process where substances, called reactants, change into new substances, called products. Stoichiometry is the part of chemistry that deals with the quantities of reactants and products in a chemical reaction. It helps you understand how much of each substance you need or will produce in a reaction. Stoichiometry uses mole ratios from the balanced chemical equation to relate the amounts of different substances. For example, in the reaction for water formation, 2H2 plus O2 gives 2H2O. The mole ratio tells you that 2 moles of hydrogen gas react with 1 mole of oxygen gas to produce 2 moles of water.